A box contains 600 screws. 1/10 are rusted. Okay. Out of 600 screws, 1/10 of them are rusted. How many are rusted then? 1/10 of 1/10 into 1/10 into 600. This much is the rusted screws. Next, one screw is taken at random from the box. Okay. So from the box, out of the rusted and non-rusted screws, one screw is taken out. You close your eyes and you take out one rusted screw, just like a lottery. Okay. Question is, find the probability that it is number one, a rusted screw, and the second question is not a rusted screw. Okay. So first, uh, here, because there are screws, 600 screws, is it possible to write all the? Is it possible to write the sample space? It is not possible, right? Because if I write the sample space, then I will have to write screw one, screw two, right, and up till your 600, right? So it is not possible here to write the sample space. But what it is possible here is to see how many elements are there in the sample space. So total number of possible outcomes. How many possible outcomes? If there are 600 screws and I'm picking only one screw at random, then how many possible outcomes?
600.
So I can choose any of the 600 screws, right? One at a time. So number of possible outcomes is 600, right? Okay. Next. Now, if you see the question is a rusted screw. So because the question is a rusted screw, I call my event E1. Let E1 be the event. A rusted screw is taken out. A rusted screw is taken out. Now,
Good morning, sir.
once I know this event, rusted screw is taken out. Okay. Now I'll see how many rusted screws are there. Number of rusted screws is how many? Number of rusted screws is 1/10, right? Of 600. 1/10 is rusted. So there are 60 rusted screws. So if E1 is the event that a rusted screw is taken out, how many outcomes favorable to this event E1?
So 60.
Only 60, because there are 60 out of 60 rusted screws. You can choose any one in 60 ways, right? So number of favorable uh, outcomes, number of outcomes favorable to E1 is 60. So therefore, probability of E1 or probability of a rusted screw is chosen. A rusted screw is taken out. Is equal to how many? Number of favorable events, 60. And total number of possible outcomes?
600.
So it is 1/10. Okay. Next question. Now, not a rusted screw. So first I define my event. Let E2 be the event that a non-rusted screw is chosen, is taken out. Okay. So number of non-rusted screws is how many? Total number of screws 600 minus number of rusted screws, right? So this is 540. Number of non-rusted screws. So how many events, how many outcomes favorable to the event E2? Number of outcomes favorable to E2 is how many? 540. Because my E2 is the event, a non-rusted screw is chosen. And how many non-rusted screws are there? 540. Out of these 540 non-rusted screws, you can choose any one. in 540 ways, right? So therefore, probability of non-rusted screw is chosen. Let's write PE2 first. Therefore, PE2 or probability non-rusted screw is chosen, who is taken out, is equal to 540 by 600, right? Which you can cancel with 6. So you get 9 by 10. Okay, and that should be your answer. Any question? And we can move to the next question then. 6 is done. Let's say number 7. A letter is chosen from the word triangle. What is the probability that it is a vowel? Okay, so the given word is triangle. How many letters in the word triangle? 8 letters, right? Let's first write the sample space. If I choose any letter from this word, then what are the possibilities? Either I can choose a T or an I, or an R or an I or an A or an N or a G or an L or an E, right? Any of these words I can choose. So total number of possible outcomes is how many? Number of letters in the word, right? Total number of possible outcomes. There are 8, right?
Sir, 8.
Now, what is the event here? See, what is the probability that it is a vowel? So a vowel is the event here, right? Probability that it is a vowel. This is the event, right? So we'll write let E be the event. A vowel is chosen, right? Therefore, what is E here? What is the set E? Which one of the vowels in this word? I.
Sir, I-A-E. I-A-N.
N is not a vowel.
Sir, it's
Okay,
not
so
an. No,
I,
no, no.
A, and E. Okay, these 3 are the possibilities. So number of outcomes favorable to the event E is how many?
Sir,
Number of
3.
3 only. So number of outcomes favorable to E is 3. So therefore, probability of E or probability a vowel is chosen is how much? 3 divided by total number of possible outcomes, which is 8. Okay, so that finishes this problem. Easy one. Let's do the next one. Number 8. 8 has 4 parts. Question number 8. A bag contains 5 red, 6 black, and 4 white balls. A ball is drawn at random from the bag. Find the probability, and you have 4 questions. So let's draw the bag first so that we know immediately how many balls we have. Let's say this is the bag in which I have 5 red balls, okay, 6 black balls, and 4 white balls. Four white. So how many total number of balls here? 15, right? Total of 15 balls I have in this, right? Now let's see what should be the sample space. How many outcomes in the sample space? What are the total number of possible outcomes? See, if I'm choosing out one ball from this, then there are total number of 15 balls, right? So I can choose any of the 15 balls, isn't it? In 15 ways. So therefore, total number
Yes,
of
sir.
possible outcomes is 15, right? Total number of possible outcomes is 15. Okay. Now let's look at the question here. Question number 1. Question is, find the probability the ball drawn is white. So let's call E1 as the event ball drawn is white. Right. So number of, because it is we won't write the events, all the outcomes in E1 because they are balls, right? You cannot. There are 5 red balls. How do you distinguish between the one red ball and the other red ball, right? All 5 red balls will look alike. And besides, how will you insert, how will you insert a notation for balls inside the elements of the set? So let's not write the elements. Let's write number of outcomes favorable to E1 is how many? See, the ball drawn is white, right? How many white balls are there? There are 4 white balls, right? So 4 white balls, you can choose one at a time in how many ways? 4 ways, right? First white ball, or the second white ball, or the third white ball, or the fourth white ball, isn't it? So therefore,
Yes,
probability
sir.
of the event E1 or probability ball drawn is white is equal to 4 by 15, right? And that should be your answer. Okay, let's see the next question then. In the next question, let's call the event E2. And what is the question here? Not black. Let's call the event E2 as ball drawn is not black. Okay, this is the event E2. Okay, number of outcomes which are favorable to E2 should be how many? How many non-black balls? How many non-black
So
balls?
9. So 9.
Yes, there are 5 plus 4, 9 black balls, right? 5 plus 4 is equal to 9, isn't it? So these must be the outcomes which are which are favorable to the event E2. So therefore, what should be the probability of E2?
So 9 by 15.
9 by 50, not black, which is equal to the probability of E2 is 9 by 15. And you can cancel this, you get 3 by 5. Okay, so that finishes the second question. Next question is red or black. So let's define our event E3 as red or black. Ball drawn is red or black. Number of outcomes that are favorable to the event E3 is how many? Which one, red or black? So how many red or black balls? 5 plus 6, right? 11, isn't it? So what is the probability of E3? Probability of E3, ball drawn is red or black?
Sir, 11 by 15.
11 by 50. That's it. Okay. Last question, last part of this question. Neither red nor black. So let's call this event E4. E4, ball drawn is neither red nor black. So how many outcomes that are favorable to E4? Which ball is neither red nor black? Yes,
So the white ball.
white ball. So if I say E4 as ball drawn is neither red nor black, this event is the same as calling ball drawn is
White.
white. Okay, ball drawn is white, right? So whether I say ball drawn is neither red nor black is the same as calling ball drawn is white. So both are the same events. So how many events that are favorable to E4? How many white balls? There are 4 white balls, right? So what is the probability of E4 or ball drawn is neither red nor black? Neither red nor black. It is 4 by 15, right? And that should be your answer. Now I have a question for you. If I ask you, um, if I say E5 is the event that ball drawn is blue. So what is the probability of a blue ball here? Can you tell me what should be the probability of a
Sir,
blue ball?
sir, 0.
6
Why?
by 15.
Why?
Sir, because it will be 0 by 15. And then,
0
sir,
by no,
0
okay,
by
0 by
15,
15. You can
if
see
we
that.
divide, it will get
Otherwise,
0.
otherwise, with 0 by 15, that's a mathematical way of thinking. Um, the no, the most common way of thinking is, or the actual way of thinking is that because there are no blue balls here, so E5 is an impossible event. Understood? E5 is an
Sir, we
impossible
have
event.
blue ball.
No, there's no blue. That's black. This is
Okay,
black.
sir. Okay, sir.
Okay. E5 is an impossible event. So therefore, because E5 is an impossible event, we write E5 is a null set. And therefore, we write that the probability of E5 is 0. Clear?
Yes, sir.
Okay. Let's move on to the next question then. Okay. Question number 9. A box contains 17 cards numbered 1 to 3 till 17 and are mixed thoroughly. Okay, just like your election lottery in the school. Okay, a card is drawn at random from the box, and then any card is drawn from the box without looking at it. Okay, find the probability that the number on the card is, and you have 5 questions. So first of all, let's write the sample space. If there are 1 till 17 cards, then I must have sample space as card must have these numbers, right? So if I have these cards and if I'm picking out one card, how many total number of possible outcomes? 17, isn't it?
Sir, 17.
Because I can choose any one of the 17 cards in 17 ways, right? The total number of possible outcomes is 17. Now, first question. Question is that find the probability that the number on the card is odd. So I define my event E1 as number on the card is odd. Number on the card is odd. Therefore, what is the event E1 here? What numbers are odd? 1, 3,
So
5,
1, 3, 5, 7, 9, 11, 13.
right? Any other?
No, sir.
So number of outcomes favorable to E1, how many?
Sir, 70. Sorry, 9.
Count, count the number here. 9, right? So therefore, what is the probability here? Probability of E1, or we also write probability number on the card is odd. And what is the probability here? 9 by 17, isn't it? Yes?
Yes, sir.
Okay. Uh, fine. Let us see the second question here. Number is even. Number on the card is even. Okay. So let's us define our event E2. This is for the second question. We are defining the event E2. Number on the card is even because the question is find the probability that the card is even. Okay. So what should be E2 here?
Sir, all the events number between
2
1 to
and 17.
17.
So list them out. Okay. Because we need to count them. 2, 4, 6, 8, 10, 12, 14, 16. No other? So how many outcome favorable to E2? Count 8, right? Oh, no, more than 8. No, it's 8. So therefore, what is the probability of E2? Number on the card is even. 8 by 17, isn't it? 8 by 17. And that finishes your second question. Any queries, any doubts?
No, sir.
No, sir.
Third question is number on the find the probability the number on the card is prime number or prime. So I define my event E3 as number on the card is prime. Okay. So let's list down the prime numbers between 1 and 17. E3. How about 1? I told you 1 is neither prime nor a composite. So we are going to leave out 1. Okay. So 2 is prime number. 3 is a prime number. 5, 7, and 11. And then 13. And then 17. These are the prime numbers. So how many outcomes favorable to E3? Out of these, I'm choosing one prime number. In how many ways can I do it? Number of primes that are there, right? How many primes are there?
Yes, sir. So 7.
There are 7. So number of outcome favorable to E3 is 7. So probability of E3 is
7 by 17, sir.
7 by 17. The card number on the card is prime. 7 by 17. And that's your answer. Fine. Next question. Number is divisible by 3. So let's define our event E4. Number on the card is divisible by 3. Okay. So what should be E4 here? What are the numbers between 1 and 17 that are divisible by 3? 3 is a number divisible by 3, 6, 9, 12, 15. And no other, right? So how many outcomes favorable to our event E4? How many outcomes? How many
5.
elements are there?
5.
5.
5.
So for probability of E4 or the probability that the number on the card is divisible by 3 is 5 by 17. And that's your answer. Okay. Last part of this question. Let's see what the question here is. Question is numbers divisible by 2 and 3 both. Okay. So E5. Number on the card is divisible by both. We define this event. Number on the card is divisible by both 2 and 3. So this is event number E5. This event is the same as, if you remember your divisibility test, if a number is divisible by 2 and 3 both, That means the number is divisible by 6, isn't it?
Yes, sir.
Number on the card is divisible by 6. So whether I say number is divisible by both 2 and 3, or whether I say number is divisible by 6, it is the same thing. So let's write down the E5, the set E5. How many elements are there in the set E5? Let's write down the elements first. Which one are the multiples of 6 here? You have 6 and you have 12. Any other between 1 and 17? No, right? Only 6 and 12 is divisible by 6 between 1 and 17. So how many outcomes favorable to E5? 2, right?
Yes, sir.
And therefore probability of E5, and the probability number on the card, number on the card is divisible by both 2 and 3. Is equal to 2 by 17. And that's your answer. Clear? I can move to the next question then.
Yes, sir.
Okay, this is a question from cards. Okay, playing cards. I told you the structure of playing cards in the beginning only. Recall that structure. Okay. Question is, a card is drawn from a well shuffled pack of 52 cards. Find the probability the card drawn is, and you have 5 parts to this question. Okay. So let's write it here. If a card is drawn from a pack of 52 cards, uh, then how many possible outcomes? Total number of possible outcomes?
So 52.
52, because you can choose any of the 52 cards in 52 ways. The total number of
Yes, sir.
possible outcomes, because we cannot list all the 52 elements, so we don't write the sample space. Okay, total number of possible outcomes we simply write as 52. Okay, next, first question. If you see, the first question is, find the probability that a card is an ace. Okay, the card is an ace. How many aces in a pack? Let's define the event first. Let E1 be the event. The chosen card is an ace. Is an ace. Okay, so therefore number of outcomes, number of aces.
So 4.
Yes, number of aces is how many? 4.
So 4
So
cases.
therefore number of outcomes favorable to E1, how many? Out of these 4, you
So
can
4.
choose these 4 aces in 4 ways.
Yes, sir.
Favorable to E1 are 4. So therefore probability of E1, or
So 4 by 52.
probability the chosen card
Sir, 1 by 13.
is an ace is equal to 4 by 52, isn't it? Which is equal to 1 by 30. Okay, that finishes the first question. Next question is a red card. That find the probability that the card is a red card. So we define our event E2. Is a red card, right? How many red cards?
So 13.
So 13.
26. Hearts and diamonds are red. 13 plus
Yeah,
13.
sir.
Yes, sir.
26.
Yes, sir. Yes, sir.
26 red cards. So number of outcomes favorable to the event E2 is how many? You can, out of these 26, you can choose any one of the 26 card in 26 ways, right? So what should be the probability of
Yes.
E2?
So 26 by 52.
Sir, half.
Yes. Probability of E2, 26 by 52, which is half. Okay, that finishes the second question. Next question is neither a king nor a queen. Okay, interesting question. Neither a king nor a queen. So e3, the card is neither a king nor a queen. Okay, so I define this event as e3. And so how many cards that are neither king nor queens? That is one question. Number of cards
Sir, 4 plus 4.
that are, why 4 plus 4?
Sir,
That are,
there are 4 kings and 4 queen.
but here the word neither is there. Neither king nor queen. How many cards that are neither king nor queen? Neither
Sir,
king nor
52
queen
So
means,
minus 8.
44.
yes, not
Sir,
king nor
44.
queen. So 52 cards in total you have.
44.
Minus and you subtract the number of kings. You have 4 kings and you have 4 queens, isn't it?
Negate लगा देगा भैया.
Yes, sir.
Yes, sir.
Right? So 52 minus 8 should be how much?
So 44.
44. So how many
44.
how many outcomes favorable to E3? 44. You can choose any
So
of these 44, right?
5.
So PE3. Be
Yes,
very
sir.
careful when you're reading the event, okay? When neither king nor queen is given, do not write it as king or queen. Okay, so be very careful when reading a question. Neither a king.
Excuse me, sir.
Yes.
Sir, yesterday I was doing my revisions of uh, of menstruation chapter, and
Hmm.
sir, I just wanted to ask that in of 18.4 will come in exam.
Which one? Uh,
Sir, menstruation 18.4 part.
18.4 mensuration, whatever I have done, that is you have to go. That is only cubes and cuboids and cylinders I have left. All others I have covered.
Yeah, sir, you have done till 18.2.
Yes.
Yes, sir,
18.2.
that only I was asking.
That's it. That's it.
That 18.4 will come in exam or
No,
not?
no,
I
no,
forgot
no,
that
no. If
too.
I have not discussed, so
Thank
it will
you,
not
sir.
come. Okay. Question
Okay,
number
sir.
4 then. Okay. Question number 4. Let us define this event as E4. What is the question here? Question here is that the card chosen is a face card. Okay. What do you mean by face card?
Sir, king, queen, ace, and
Not
cards.
ace. King, queen, or jack. When you
So
take
Sir,
king,
jack.
Jack,
king, queen,
or
ace, and jack are honor cards. Okay.
so Jack, King, or Queen.
King, queen, and jack only. How many cards that are face cards? How many face cards? 4 kings,
Sir, 12.
4 queens, and 4 jacks, right? 12. So number of outcomes favorable to E4 are 12. So what is the probability of E4?
Sir, 12
Probability
by
the chosen
52.
card is a face card. Is 12 by 52. You can cancel with 3, with 4. 3 by 13 is your required probability. Okay. And the last question. A card of spade or an ace. Okay. Card of spade or an ace. Question number 5, event E5. Card is a spade or an ace. Interesting question here. Okay. Number of cards that are either a spade or an ace. How many cards that are either a spade or an ace? Now see, how many spades are there? How many spades?
13.
There are
13, sir.
13 spades, right? Now this spade includes one ace, isn't it? Is included in this.
Yes,
So how
sir.
many remaining aces? 3 aces
Sir,
remain, right?
3.
3 is.
So
So
total
total
number of
16.
cards, yes, that means the card that either a spade or an ace is 16. Understood the logic?
Yes, sir.
Okay. So how many events favorable to E5 are 16? So PE5 is the chosen card is a spade or an ace. So this is equal to 16 by 52. I think this should cancel with 4. This is 4 by 13. Is your answer. Okay. So I'll stop here.